Hello everyone, very good evening to all of you. Let me share my screen to you guys first. Okay, let's get started. Good evening Vishnuvardhan, good evening Raghunath, good evening Sanjay, good evening Aditya, good evening to all of you guys. Okay, Mm. So we'll be doing some fun stuff today. We'll be figuring out how to use NumPy, Pandas, Matplotlib all together in let's say 1.5 hours. We will try. Okay, let's see what actually happens. Okay, but we will try and let's see how it actually goes. Right. So let me just name it by Pandas and what we have Matplotlib. Well, this is not a total NumPy tutorial, Pandas tutorial, Matplotlib tutorial. It is more oriented towards the use cases where exactly you can use NumPy and where exactly you can use Pandas and Matplotlib respectively. Okay. So how many of you have used NumPy, Pandas, or Matplotlib? Anyone like who has ever used in their projects? Anyone? So meanwhile, I will just going to tell you how to install NumPy Pandas. So pip install NumPy Pandas and Matplotlib. Okay. Well, in this manner, you will be installing three libraries. Okay, one by one, not simultaneously. So first we will be having the NumPy, then the Pandas, and then the Matplotlib. All right, the last one. Okay, here we have a lot of people here who actually have used NumPy, and some of them haven't. Okay, all right. So Yogita never has used it. All right, okay, but not in projects. All right, cool. So first we must understand what is the NumPy in the first place. NumPy basically helps you in scientific calculations. It helps you in matrix multiplications. It also helps you in linear algebra, right? So it's a go-to tool for the people who are working on any analysis project, even for even like scikit-learn or pandas or even Seaborn, like they uses NumPy's array mechanism under the hood. Okay, why? Because it is pretty much optimized. It is like none, like if it is not like 50, like it is more almost like 50 times faster than the traditional Python arrays. Okay, that is why we use. And even in the programming that we usually do, what we do, like we tend to focus more upon if your program is efficient or not. Like if it is taking 10 seconds or 20 seconds in order to run an algorithm, like and it is totally futile, right? Even on the 10 data points, like let's say if I have let's say like 1,000 data points, and to calculate those 1,000 data points and even to operate to perform some operation on those 1,000 data points, if my algorithm or my steps actually takes around like 10 seconds, like then my code is nothing but a trash. Honestly, it is, because the moment you will go, you will be dealing with the larger data set. Like you may have to wait for years in that case. Okay, well, we don't have that much time to solve those issues that actually came along with the Python's data structure list, right? Okay, like though those lists was super terribly slow, and that is why NumPy came into the picture. And NumPy under the hood actually was written with this C++ and has been wrapped with the Python wrapper. Like that is another case study to talk about. Okay, So, in a nutshell, like NumPy helps you in order to create or in order to do some scientific calculation with an optimized manner, like the faster than fast. Okay, and it's an improvement on the Python's array mechanism. How? Let's see. How do we define an array in Python? Like this, right? What if? What if, like, let's just not do this. Like, let me just do somewhat like it is. Mm-mm-mm. Let's just have allow almost like 1,000 values, 10,000 values. Okay. Now what I want to do here, I want to multiply each and every value from 1 to 10,001 by 2. Right. I want to multiply each and every value which produces this array. Like, let's see that array in this manner as well. These are the values that we have right now, and you can actually see the last value that we are having right now is the 10,000. All right. So how can we do that? Like, my task here, my task here is to calculate the double of each number presented an array. Right. So how can I do that? The first option that I can have, like, let me actually ask you, will this going to produce array multiplied by 2? Will it going to what will it going to do? Like, what will be the output with this statement? Can anyone tell me what it will going to produce? What will be length? What will be the length for this? Can anyone tell me what will going to produce for us? Anyone? Come on, tell me. Array multiplied by 2. What it will be, producing for us? What it will be? No one? Right? Wow. Okay. Array multiplied by 2. I am just waiting for your answer. I multiplied by 2. Right. Uh, right. I just doubled up this. And what I'm going to do here, I'm just going to convert this of this. And of course, I don't want this. And neither I want this. Okay. Okay. So range का multiple. Range का multiple. What do you mean by that, Yogita? 2 multiplied by length. So print 2 times. It will not going to print 2 times. Rather, it will just going to add 10,000 new, no, 10,000 identical values from 1 to 10,000. Like, what you will be having 1 to 10,000, and then again it will going to start from the 1 to 10,000. Like, if you actually have to see a smaller example, let's say when you have 1 2 3 5, multiply this with the 2, it will just going to produce 1 2 3 1 2 3. It's basically what we are saying. We are just extending our present keyword, our current array, with an identical one. Right, this is what it actually does. Okay. Right. So let's actually calculate the time for this process. How much time does it take? Right. And let's see how much time we actually take in order to calculate the values from 1 to 10,000 and doubling them up and here. All right, how can we do that? That is how we can do that. Like, I'm just iterating over each and every value here and then appending the twice of it from this array. Okay, let's do this. And the time that I actually got here is 5.17 milliseconds. Okay, not bad. Like, it is the time has like a 10 multiplied by minus 3, like 10 raised to the power minus 3 multiplied by 5.17 seconds. We can call this out as like this, right? This much time it actually took to run or to calculate, and also store and everything whatever you are seeing right now. Okay, this much time it actually took. What if we do it numpy way? Right. How exactly it is? First, and for the most, what you first need a numpy array. Okay. So in order to use a numpy array, you must import the numpy, right? And now I want to convert that numpy array. I would call it array np. Okay. Let me just import it somewhere before that. Here. Okay. Now we have array np, which takes np.array, and we can pass on the same thing. Let's just actually pass on the same thing here. Okay. Now what we will gonna do? Array to np, array np multiplied by 2% time. Okay, it actually took us, shouldn't have, but okay. Now if we actually run this multiple times, this is somewhat like, let me actually make it somewhat more this. Okay. It's taking now 60.25 milliseconds, and this one actually is taking around like, or the five zeros, and we have here four zeros, 5 1. Now we have five here. Okay, and let's actually calculate this out. Okay, it's weird actually. Okay, now yeah, it's now actually giving us lesser time. Okay, so now you can actually see here. Okay, but basically what happens usually, like, uh it is weird. Sometimes it actually behaves weirdly. Okay, so what we are doing here, we are just calculating the multiplication of 2 for each array, each value that exists in this array, right? Okay, and that is what we are passing on here. Okay, I believe if we actually pass on here as array simply, we're going to reduce the time. Yes. If I actually go it from here, but you can actually check this out. But you actually saw here. Okay, if I had to do here for like the million values, these are like already 100,000. Okay, for the million, I just have to add another zero. Okay, this loop will going to run million times. Whereas my numpy array, what it does, what we did, like, we just did the multiplication of 2. That's it. And how exactly? Like, there is a concept called broadcasting, right? Okay. So you can see right now, like, we literally terminated the entire looping. Like, there was a loop here. Now we don't have any more loop here. Or you can also, what we say, like, what we say, like, make sure like we are having the values. Okay, like for 1 to 10 we are having the double values here. Okay, so that is why people usually prefer numpy. Why? Because it is optimized. They reduce or eliminates the loops, and which is always a good thing for any programming, like for any algorithm, right? It always reduces the time complexity, and yeah, they are much better than the traditional Python arrays, right? Okay, so let's do some fun stuff with those. Okay, how exactly? Okay. So since we have already imported the numpy here, what we can do, like, I have a habit of seeing the method by this manner. What I usually do, like, there are bunch of methods, like, I can't even name every. So what you can do here, np, just do it like that way, and you will be having every value, like whatever it actually consists. Okay, and let me actually print this value out. Okay, so dir actually produces the class functions and everything, and the variables and whatever it actually whatever it actually holds. Okay, so like we have almost, what we say, like, we can actually calculate the length of it. Okay, so let's actually calculate the length of it. So 609, like, these are bunch of them, like, we won't be ever using those, like, hardly 5 to 10 or maybe 20 max. but not all of them for sure. All right. So first, let me actually show you some of the fun stuff with those. Okay. How do you find the mean of the values? Mean of an array. What is the mean of an array? With a traditional with a traditional array, what you have to do, you need to write a program, right, that actually takes an array and returns the sum of the array, sorry, divided by length of the array. That is your mean, right? And when I actually calculate the mean of the array, what it is, it's 3.0. But whereas if I actually calculate the mean with uh, numpy array, you can just simply pass on, like, let me just pass on the array here and print array np dot mean. There you go, right? So we have scientific calculations like mean, standard deviation, right? And normalization is also there. Okay, so you can perform bunch of things. And what about like creating random values? And where exactly they are useful? Firstly, like I could actually generate any values, right? But where exactly they are useful, you must understand this. So when you are training a model or something, okay, so you tend to initialize some basic or initial weights. Okay, so that's where you might actually generate some random weights in that scenario. So that is where the np dot random comes into picture, right? So how you can do that? Np dot random, we have a class for that, and I'm just going to perform this. Okay, and now you can see right now like what it actually holds. Okay, these are the apis of this rand rand f, random floating values. Okay, like you can see uniformly distributed values. I'm not sure like if you people are aware of the bell curve or not. Okay, these are the values that you can generate with the random class. Okay, so let's actually generate some value here. It is generating some value, and what it actually takes here, it takes dictionary for, like, not the dictionary, for the parameters. Let's say I want to calculate, I want to see for like 100. So 1 by 100, basically 1 by 100 means uh, having one value in it, and with the 100, like one row with the 100 columns, sorry, 100 columns, like this, not like this. Okay, so I hope like you can actually read this value out, right? So let me actually have this value in an array. Okay, so how can we calculate the order of that array? Array dot shape. Okay, and what about like calculating, what about generating some other values? Random dot rand 3 by 4, array dot shape 3 by 4. It's quite obvious, right? Okay, all right. So when you actually print the value out, these are the randomly distributed values. How many of you know about the randomized like bell curve and normalized distribution values? Have you ever heard about those, like those terminologies? PDF, CDF, something something. Have you? Okay, so meanwhile I'm going to, what I'm going to do, just, it's your mp.random.random. Okay, and what about like this is actually uniform. What about the normalized one? Well, in that case, what you can do is np.random.randn. Okay, and it will just going to generate the randomized normal values. Okay, and there you go. It actually produces normalized value, which okay, normalized values. So how many of you know about the bell curve though? Uh, uh, uh. Okay, so these are your normalized values. Okay, like you need to understand the normalized values first, like what they are. Like we tend to follow normalized value tend to follow a pattern, what we call it as 95 9, like no, wait, 68 95 99.1 rule. Okay, so what it does for where exactly it is. Okay, people have no idea about. Don't worry, I will teach you. All right, Dattatreya. Mm-mm. Normalized values like normalized follows a rule called 68, 95, 95. Look, why am I actually teaching here? 99 rule. Okay, 99.7 rule. Okay, and you can actually go in here, Wikipedia. What exactly it does, like I hope you can see right now. Okay, this is quite clear. Okay. Uh, Let me shift this here just for a while. Okay, so I can actually explain this. So what exactly is happening? Like these are actually what we say, what we call those, like these are normally distributed values. All right. So 68% of data where exactly it falls in if the values, the given that if the values are normally distributed, all right, if values are normally distributed, wait a minute. Okay, now it's working. Okay. So if values are normally distributed, right, then and only then we can apply this rule. And what exactly it tells us, right? What exactly means 68, 95, 99.7? What the hell does it even mean, right? So let me actually give you a brief about it. When we know our data actually follows a normal distribution, and by distribution basically means like the bunch of numbers, honestly, those numbers actually follows the normal distribution. When we have number, can we calculate the mu, which means mean, right? We can calculate. Can we calculate the sigma, which means standard deviation? If we can have those two, right? If we can have those two, we can literally calculate the what we say the proportion of a data set with what I can say like 60% of the data falls between mu minus sigma and mu plus sigma. What do I mean by that? Uh, let's assume let's assume a case where heights of Indian men are what we say follows a normal distribution. Okay, well in that case, if you have mu, let's say the height for the mean or average height is there like 170 centimeter. Sorry, 170 centimeter, and the deviation is minus sigma, which could be like let's say 10 centimeter plus minus. So I could just literally write for the 68%. I can just say 68% of the Indian men height falls between 160 to what 180. Can I say this based upon these two values? Can I say this? Yes or no? Right. What about the 95 though? What about the 95 though? Okay. So now I can say mu minus 3 sigma and mu minus 2 sigma and mu plus 2 sigma. I can say for minus 2 sigma, I can say 13%, 13.6% of the population actually falls in here, and 13.6% of the population falls in here. Right. And same I can say for this. Sorry. Same I can say for this. Okay, so when a distribution follows a normal, what we say, a distribution, like when some bunch of numbers actually follows a normal distribution, we can use 68, 95, 99.7 rule to make some observations, to make some like what exactly is happening under the hood, right? Okay, have I made myself clear here? Okay, all right. So yeah, let's just see. So these are your normal distribution value. No, no. 0.3% is not the outlier value. We don't usually consider them as outliers is something. Outlier, if you really want to check for the outliers, why don't you check for the, you know, techniques like anomaly detection and curtices to actually detect those, just not those outlier. Okay, just don't get confused here. Okay, so this is how you can actually generate some normalized values, right? Okay, and now what if I want to have, let me actually ask you a question here. Okay, let me actually make you ask you a question here. Okay, what is the, I have an I have an array, I have a matrix, right? I have a matrix here, okay, that has three columns and four rows. What is the order of this? Like simple, 3 by 4. It's quite straightforward, right? Okay, okay. What about if I have this, can anyone tell me the order of this? These are the four and this is three, basically three columns and four rows, three column and four rows. This is a matrix that consists of these two matrices. How many of you can tell me the order for this? Can anyone tell me the order for this matrix? Anyone? Okay, four. Anyone can tell me the order for this matrix? 1 by 2, 8 by 6. All right, let's actually butcher it down. How many rows do you see? Like, let's actually forget that these are the matrices. How many rows do you see here? How many rows do you see here? Just tell me, like, for the outer array, how many rows do you see here? Two, right? Two. Yeah, exactly two. These are two, one and two. And each row consists of what? What array? What order of matrix? Two by four by three. So can I say like I have a matrix which has the depth of two, has a uh, order of each matrix as 4 by 3. Can I say this or not? 8 rows, where exactly you are seeing the 8 rows? These are not the 8 rows. Okay, let's actually define some. Okay, so you can actually have better idea. Multi-dimensional arrays, right? np dot array. What if I actually define some arrays like this, 1.23? What if I define someone like this, 456? Okay, and we can pretty much sure, like we are pretty much sure, like the shape of these is, this is like 3 by 3. Oh, sorry, 2 by 3. Okay, so basically we have only two rows and three columns. Okay, pretty much straightforward, right? What if, what if I have this 2 by 3, this 2 by 3 and multiple, like in multiple format. What do I mean by that? What if I have 2 by 3 here? Okay, and also here, right? Now what we have, if I actually have to somewhat make it somewhat readable, I just really have to just understand this in this manner. Okay, like let me just break it down here so you can understand this in a better way. Okay, yeah, क्या हो रहा है? Just a second, guys. Sometimes my computer sucks. Honestly, it does. All right. Uh-uh. This is what it is. All right. So now I hope you can actually read it somewhat. Okay. Let's not focus upon this. Okay. So now you can see I have an outer array, right? I have an outer array which has this array. Okay. Let me just also separate it down. Which has this array, right? For this array, what the order for this array is? What is the order for this array is? Basically for this is 2 by 3 and also for this 2 by 3, right? If I just have to, let me actually copy this out and paste it here. And right, so what if I actually see the array here. What if I actually check this out here, like it has the order of 2 by 3, right? It has the order of 2 by 3. But for this outer array, how many rows do you see right now? Like this is enclosed by one array, like total in one array, first row, and this is enclosed by second array, second row, right? So can I say this, like for this entire array, my shape is 2 by 2 by, sorry, my matrix shape is 2 by 2 by 3. Have I made myself clear here or not? Please let me know. Have I made myself clear here? Okay. Okay, so that is how you actually deal with the three-dimensional arrays. All right, pretty much straightforward, right? Okay, so let's actually see more of those, right? Okay, this is your multi-dimensional array, and we already saw the 2D arrays along with that. Okay, okay. What if I want to calculate? What if I want to calculate that condition, conditional based arrays? Right, what they are exactly? Say I have an array. Let's say I have an array. I want to calculate how many of the values of this array actually more than 3. The first way, the option 1, what I can actually choose here, the option 1 here could be this, the following method. Okay, option 1 here could be like this. Array result. Let's actually calculate an array result, right? And now what I want to check, if for I an array, if I let's say greater than 3, then I'm going to append, let's say dot append true, else it has to append a false. Okay, and when I actually see result, and let me just print that value out. Now I have like this, false, 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 true, 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 right? Pretty much straightforward. But as I told you earlier, what does numpy array do? Like they literally reduces the elimination, like they literally do elimination for the looping, right? Okay, so that is what we will gonna do with this. How exactly? With the help of np dot where, right? So let's take a condition np dot where, what exactly it does, and let's actually see the documentation here as well. It takes a condition, and if the condition has been met, then it will going to produce some result. Let's say if you can actually see here, I believe you can. Okay, like for example, like the same example we are taking in right now, like if the array is like you can see for this example, let's actually try to understand from this example. You can see, I believe it is not visible. Okay, let me actually make it somewhat visible. Okay, I believe this is now visible, and if it is not, I'm just going to, this actually sucks. Basically, you just can't zoom it out. Okay, let's actually bring the help now. This is the last option. Okay, so now you can actually see here, right? We have np.a range, right? And for that, we are producing this many values for the array. Now, what we are checking out, if array is less than 5, then let it actually be the same value. If it is more than that, multiply it with the 10, right? Okay, if it is less than this, let it be same, otherwise. So this actually follows a true, and this follows the false value. Okay, so let's actually see that. Okay, so false value, on the false value, I'm going to have a false value, and for the true value, I'm going to have a true value. And condition we have right now is I my value, let's say what we say, np dot where. Okay, so what we are saying right now, okay, so if the value, if the array, okay, so if array is greater than what we were talking about, like right now, like the 3, I believe. Okay, let me again see that out. Okay, yeah, 3, this is your condition, right? I hope everyone is on the same page with me. So np dot where, now I'm going to put in the condition, then the true value, then the false one. Boom. Not supported between. Okay, yeah, yeah. What exactly is happening right now? We need to convert this into np dot array. I actually forgot to mention like the broadcasting. Like I did not. If you remember here, this is actually a broadcasting, guys. Sorry, I actually forgot to mention here. Broadcasting. What exactly does it mean? Helps you perform an operation on a have to perform an operation on whole array. Okay, without looping, basically. I have to put it in a layman terms. Okay, so that is what we are doing right now. We didn't loop over anything. Okay, and now it should be working. So yeah, so now you can see we are getting the same value here. Okay, where exactly it is, like if we see here, array result, this is what we had. So false, 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 true, true, true. Now you can also see the condition is here, this. If the condition is true, then it should be true value, otherwise it should be the false one. Sorry, have I made myself clear here or not? Please let me know if not. Okay, that is how you can actually use yeah, numpy is totally superb. Yes. Okay, and that is how you can actually use numpy for the condition based evaluations as well. Okay, but unfortunately we won't be delving so much into it because we have to cover pandas as well and matplotlib as well. All right, so we're just going to hold our numpy theory here, NumPy programming here. And now we're going to start with the pandas. Right. And what exactly is the pandas? It's like it will going to come in when we are dealing with the NumPy for sure. Okay. So what exactly it is? Pandas is a data manipulation tool or a library. What exactly do I mean by that? When you want to manipulate data, let's say you want to filter out some missing values, when you want to some filter out some duplicate values, when you want to drop some duplicate values even, right? And also perform a bunch of operation on an entire column, how exactly you can do that? Well, in that case, pandas comes to rescue. All right, so let's do that. So let's actually study about the pandas now. So import pandas as pd. Okay, we're just importing the pandas simply here. Import pandas as pd. This is alias, right? Like why I'm saying right now here is like uh, I'm going to call pandas as pd, right? This is what it means. Okay, so now let's actually define a data frame first. How exactly we can define a data frame? So see here, let's say column 1, 1 2 3 4 5 6 7. Column 2, what I'm going to do here is this a b c d e f. Column 3, true multiplied by 3 plus false multiplied by 4. I hope this is clear. Okay, now we have d here. Okay, true true true, false false false. All right, now we have d here. Okay, and now let's convert this value into a pandas data frame. Yeah, we can also do data aggregation as well. Ready? Sorry. Okay. So df pd dot, we have a data frame function here. All right. How we can actually call this method out? Simply pd dot data frame. Boom. And now we have a df. Right. Okay. So how exactly I like this is nothing but a simple calculation, and we are concatenating two arrays here. First, I actually took 3 trues and 4 false, and then simply added them up. That's it. Right, and this is nothing but a dictionary which has a key value, key and pair value, whereas key we have like column 1, column 2, column 3, and the values associated with our 1 to 7 a b c d e f g h e f g and these values. All right. Okay, so I when you want to create a data frame, you just pass in the data frame, or sorry, in the dictionary into a data frame, and that will going to produce you somewhat like this data frame or this structure of data. All right, and you can do bunch of stuff with this data now. Like let's just actually calculate, what if I want to see what info does it hold. I could read any file here, right? What info does it hold? You can just call it you can just call out the you can just invoke the info method here, and afterwards you will be given like the d type that we are having 7 values. Okay, and in the column 1, so you can read this out value quite easily. Column 1 has 7 non-null values, which has a data type of 64 into 64. Okay, also for column 2, 7 non-null values, object basically means string is here. Okay, and for the column 3 we have 7 values, and for the bull, what if I want to check the values out now? So what you can do here instead, you can just type in the column name. So column name is 1 2 3 here. I'm going to go with the 3. Okay, this is your value, true false true false. And if you actually remember, I stated earlier like pandas or c++ under the hood use numpy array mechanism to confirm this. What you can do, just type in values. Okay, okay, it is not. Okay, now you can see this is a numpy array. Like you just to make you more sure of it, just type in type, and this is a numpy array, right? So pandas do use numpy arrays. Okay, so now you can actually also say like we can also create some data, some exciting data with the numpy array itself, right? So let's do this. How we can do that? It's quite easy. NumPy and pandas. All right. So we have a NumPy array. Let's call it a 3 by 4 array, but let's not call it directly 3 by 4. Okay. NumPy array random dot random, and I'm just going to call it like 10 by 10. Okay. No, 10, not 10 by 10, but 10 by 4. Okay. Because I don't want to give, yeah, you get the gist. Like, I don't want to give four names over and over. Okay. So right now I have 10 columns, sorry, 10 rows and 4 columns here. I want to convert this entire thing into a data frame. How can I do that? Simply pass in this value, and again, sorry, pd, again, sorry, pd dot data frame, and what after do that, def, and boom. Now you have the values. Whatever were the values that we generated here with the np.random.random, now we converted those values with the help of what? Simple pd.dataframe function. Straightforward, right? Okay, so what if I want to change these columns out? Like, I cannot interpret anything from these columns. 0 1 2 3, what do they say? Like, I can't tell. Like, but I know the column names here. How exactly we can do that? Like, there could be some of the methods here that you can actually perform. Like, for that, uh, option one that you could have is this. Okay, let me actually, option one, okay, that you can have is columns. Let's name them as A, B, and C, and D. Okay, right, these are the columns, and the moment I do that, I have now column values as well. What if what if I want to change the column names as well? So these are the columns, and now I want to change column 2, column 1, column 2, column 3, and column 4. Okay, now I have column 1, column 2, column 3, column 4. So it was quite easy, right? For the columns A, B, C, D, right, we gave it here A, B, C, D. But if we don't give it, like, there will be 0 1 2 3, and not so much readable. Afterwards, what we are doing here, like, we don't like the name ABCD either. So what we are doing, we are just replacing ABCD with the column 1, column 2, column 3, column 4, right? And the moment we do that, bingo, you have changed the name of the columns as well. Okay. Okay, so yeah, that is what you can do with the column parameter here that is being provided by the pandas here, right? Okay, and apart from that, what if I want to check the values or want to describe the values? Well, what you can do here, you can just describe the value here in this manner with the describe function. Okay, so you can see, like, the count first, or the index value or parameter that you are seeing right now is 10. What does it mean? Like, we have 10 non-null values. Okay, and each of those 10 non-null values has a mean of this much, has a standard deviation of this much, and has a minimum value of this much. And this is actually a percentile value, which means 25% values are less than minus 0.4285. 50% of values are less than 0.22 minus, and 75% of values are less than 0.51. I hope you actually can read percentile values, right? IQR1, IQR2, IQR3. Okay, this actually represents that, like, and afterwards we have the maximum value. Maximum value tells uh, how exactly you want to change the percentile. Sahi, Harsha? Like, you are asking me to manipulate the data. Of course you can change the percentile the moment you will going to manipulate the data. Yes, so answer is yes, you can change it. Okay. Okay, so that is how you can also see the describe method here. All right, and uh, 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 what about what about the, what if I actually wants to convert this entire value into a CSV1 and again wants to read this value out. Well, you can do that too. Df dot, yeah, you can do that, but you have to do the manual calculation for that. Okay, 30, 50, 70, it can be done, but you have to do the 30th percentile on your own on each column, right? Well, you can write a simple function for that. NP dot percentile is also there. Okay, and I believe what you can do here, you can just simply call np dot percentile. Okay, and what it does, it takes the array value a and q, right? And afterwards you should be good to go. Okay, and you can also see the example here how it can be done. Like you can see here, uh, it is actually calculating the 50th percentile for this array. You can pass in here 30, or you can pass it here 50, or you can also pass in here 70. All right, so you can use np dot percentile and can change the entire column with that those values. Okay, have I made myself clear here? Okay, and you might actually ask, how can you even change the column of those values as well? Like you can for certainly, like let's just say list of range of 1 to 11. Okay, so we have 10 values, and now actually when we see, we just change the entire column value as well. 1 2 3 4 5 6 7 8 9 10, right? So quite straightforward. Okay, okay, so yeah, you can just calculate the np dot percentile here as well. Let me actually show you. What if like you can actually, what you can do here instead, np dot percentile df of call 3. Okay, and dot values, and let me actually calculate the 30th percentile. So this is your 30th percentile, right? Straightforward, quite. Okay, all right. Okay, uh Garaj is saying this sucks. What a language. Well, honestly, if you actually have never coded in any other languages apart from Python, well, I have a bad news for you. Okay, so you might actually find Java or JavaScript or C++ pretty much repulsive. All right, so this is actually pretty much straightforward English, honestly. Or chances are you have never coded maybe in your life, so that is why you are having problem. Okay, so just stick around, Garage, and you might actually find it somewhat plausible to your understanding. All right, if not, yeah, choice is yours. Okay, all right. Okay, so that is how you can actually see the described method. That is how you can actually can use the described method as well. Okay, and the last but not the least, and what if I want to plot the values out now? Well, you can do that too. pf dot, first actually let me calculate the values of it. Value count. Wait a minute. Sometimes my system just sucks a lot. So what does value counts do? Like it calculates the each and every value in a column and tell us the number about it. Like let's just say we have a new data frame that takes the pd dot data frame. Okay, and that has a value of, let's say, column 1, and let's say 1 1 1 2 2 3 4 5 6, right? Now I want to check, like this is my column. I want to check how many ones do I have, how many twos do I have, and how many threes do I have. So you can just simply call this value dot counts. Okay, so now I can tell I have three fours. Sorry, I have three ones, two fours, like 1 1 1 2 3 5 6. Okay, and it always rearranges this for ascending order, right? So we will learn full data science in this course. Like I would love to teach you full data science in 7 or maybe let's say 1 month, but it is not possible. Data science is honestly a research field, and it requires time, it requires patience. Okay, and more importantly, it requires interest. If you are willing to put some effort, if you are willing to put some frustration into solving a business problem, well, data science will welcome you. Otherwise you will be left with the frustration and will going to say like it sucks, right? Okay. Mm-mm-mm. So this is your data frame. This is your, that is how you can calculate the values. What if I want to calculate the values? Do you know like we can also plot the values out? Yeah, with the pandas. That is that is what I actually wanted to tell you. That is what I actually wanted to tell you, Sayersha. Okay, or to every student here. Okay, so let's say we have an array np dot random dot run n. Okay, let's say we have 100 by 100 values. Oh, not 100 by 100. Let's actually have it. Okay, 100 by 100. I don't care now. Df should be pd dot data frame, and that actually takes the value. And now you can see we have values for 100. What if I want to calculate the histogram, or I want to calculate the simple hist for this zeroth column? Like if I actually, this is my zeroth number, right? Sorry, not here, but oh, actually those values are an integer, right? Okay, yeah, those values are integer, but why don't we actually, like, it won't be possible though, like having the value here, like converting all the values here. Okay, so let's actually see the values here columns. Like it actually starts from 0 to 100, so you can pick any values that you want to make a plot on. So I am just going to stick with these 7, let's say. Okay, plot dot what functions that we can have. Okay, you have multiple functions here. Okay, you can plot a histogram, you can plot a line plot. Let's actually stick with the line plot here. Plot dot line, and boom, this is actually a line plot which doesn't make any sense. Right. Let's actually plot a histogram though. So I'm just going to call it out hist. Uh. Okay, this is your histogram, guys. Okay, and this represents a simple, like not a bell curve for sure, but it does represent somewhat like a distribution which has the maximum value of like maximum value of like -1 to 0, -1 to 0, or I don't know what exactly it is. Let's say minus 0.56 something, right? Minus 0.56 something, right? So let's how exactly we can read this out. -1 to -0, we have average value of 15. So this many values do we have? Like this is actually, this tells us the frequency of each interval. Like histogram in itself is a topic to talk about. Okay, yeah, okay. So okay, so why this course is not for a week then? Yeah, we could actually extend Piyush for a week, but the thing is, even after the week, it wouldn't be possible to cover up everything. Okay, so what we are doing right now, like we are just giving you a glimpse of how exactly the pandas or numpy or the data science actually work. Okay, so you could have a better understanding, and you could have a better, direction where you need to proceed and where you want to proceed. Okay, right. So that is how you can plot the some values with it. All right. Okay, and what about plotting out some other values? Like what I do again, dot plot dot, and you have this. So you can also plot the density. There is a kd for probability estimation that we usually use. It is best for the to actually check out the central tendency. Right now you can actually see this is actually making a beautiful bell curve, right? Okay, so this is actually a normalized value. If you actually remember here, we calculated the normalized value, right? Okay, okay, so yeah, that is why we are getting this. Okay, what exactly the KDE tells us is a different thing. Like it tells us like for the how far we actually go away from the central tendency, it tells us like this many values do we have. Like for example, For minus 2 to 2, if you actually, let me just save this image in ML or somewhere, let's say mm, desktop, download.jpg, and if I actually upload an image, okay, download.jpg, right? So now you actually, if you guys actually notice here, right? So now you can actually, how many of you can actually say for this to this, I have the density. Like you can always calculate the volume if you have the density. Like if you remember the name, if you remember the formula, okay. But we can say the density for this interval is quite thick. Like we can say for the values that we are having a lot, like for the minus 2 to 2, we are having a lot of values for this value, like for this interval, and we are having least value for this interval, again interval, right? So if you actually have took my previous sessions, right, so you must have actually saw me explaining the histograms, right, where exactly I explained like how exactly it's nothing but a accumulation of previous intervals, okay. And that intervals, the moment we actually smooth this interval, smooth means basically doing this, we are taking the smooth estimation. So the moment I actually do that, the smooth estimation is this, just approximate, okay. This is smooth estimation of the estimation of what your histogram, of your histogram, right? So I can say the smooth, uh, when we smooth the histogram, we actually get this PDF plot. It's actually a probability density function plot, okay. Probability density function plot, okay. I hope it is clear, okay, right. Okay, that is how you can plot with the pandas, right. Last but not the least, matplotlib. And what exactly it is, like you, in order to install matplotlib, you just have to perform this matplotlib, right, and just put an exclamation mark here, so your system can actually recognize as no. So what you can do, so import matplotlib dot iplot as plt, okay. We will be using the pyplot function, and we I just gave it an alias of plt, that's it. Okay, I hope this is clear. All right, so what we can do here instead, like let's just say I have an x value, like what if I want to plot something scatter, like I want to plot these scatter values, how can I do that? Like it takes the x and y values, let's actually give those values here. X is equals to mm, 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 say any value like 11, 21, like this will be somewhat out of the scale. Let's actually bring them, let's actually keep them in the same scale. 50, 4, 23, and 45. This will be a y, but with different values, of course. 21, let's say, let's call them 30, 44, call that like mm, mm, 13, and 65. Okay, and now it takes the value of x and y, and boom, I have an I have a scatter plot, right? If you actually see here, the value that I am having right now, like you can see for the x 21 and y, what the value of the y has to be. It has to be not x, not no 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 not for the x 21, but for the x 11. It is the 11 for the x here, and for the y it is 21. So now you can check like this is the value that we are plotting it out, right? X comma y, right? So this is your x comma y. Okay, this is again your next x2 comma y2, x3 comma y3. This is your scatter plot. All right. What if you want to check the size? You want to change the size of it. How you can do that? Quite straightforward. 100, and now you have somewhat bigger. Okay, changing the size. Okay, what if you want to change the color as well? Key, and let's actually call them as K. And now, boom, K actually tells for the black color. All right, or tells for the red one, of course. Okay. What if you want to change the markers as well? You can do in that case, marker, and I want to have a caret sign or triangle sign. Okay. So now I will be having triangulars. All right. Is that clear or not? All right. So what if I want to have different set of data sets? Hmm. Let's have those. Okay. This is my data one. I'm just to copy, going to paste this out here. This is my x1 y1, and this is my x2 y2. I want to print x2 y2 on the same plot but with different colors and different markers. Okay, how can I do that? Let's actually first 31, let's have 71, let's have 10, let's have 90, let's have 40, 24, let's have 60, not 60, 97, let's have 33. Just making sure like I don't repeat values. That's it. 93, and I have 19 and 29, 25. Okay. And now what I'm going to do here is, okay. And instead of having x1, x and y, I'm going to have x2 and y2. And I'm just going to have a green color, but with an O marker. Okay. So let's print those values out now. Boom. Now I have those values, but like, what if I could also label those values as well? Like, just by looking at those values I cannot tell if this value, if someone actually make an attempt to take a what we say, just take a look at this graph and say like I really can't tell for if x1 is from green, or if this point is from the x1 y1, or if this point is from the x2 y2, like we cannot tell. Okay, well in that case what you can use markers. Markers, not no markers, but labels, sorry. So label. Okay, I'm just going to use label from, I'm just going to call x1 y1. Okay, and for the label I'm just to call it like from x2 y2 plt dot show. Okay. Now you can see like even after mentioning the label, why we are not getting any labels? Well, in order to invoke the labels, what you need to call up here, legends log is equals to best. Log based best actually tells you the where exactly it should be placed at. This legend, okay, you could have like other values as well, but it automatically calculates the best location and puts the legend over there. Okay. Okay. So yeah, so that is how now I can tell like this red value is from x1 y1. Okay, and this uh, green value is from x2 y2, right? I hope this is clear. Okay, all right. Uh, uh, uh. What if you want to give some X label and Y label as well? How you can do that? Well, it's quite easy. Just pass in plt dot X label, X label. Simply, you could have any label, but just to be more generic, I am not using any different names. Okay, Y label. Uh, 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 uh. Now you can see I have X label here and Y label here. All right. I hope this is clear. Okay. So that way, like that is your PLT start scatter function. Okay. And the same way, we can also plot out the hist values. We also already have some df.0 values, right? We also got the same plot with what? Our df0 here. Like I don't remember, but yeah, we also got our same plot here. So you can also calculate the histogram with the plt.hist. And if you don't want to show up this weird array messages, like these are the histogram values, okay? And what you can do in that case, like this is your histogram. All right. So how to set the limit for x's? Like x limit, there's a function in matplotlib called x limit, y limit. Use those. You should be good to go, Sai Harsha. Okay. Right. All right. So this is your matplotlib. Like it won't be possible, honestly. Like we have around like maximum 10 minutes more. Okay. And it won't be possible to cover up each and every function of it. Okay, let's check how many functions do we have. Aggregation, like a lot, honestly, a lot. Okay, so what I can say here, like what if I want to check out how to plot line with matplotlib? What I will going to do, I will just going to simply type in matplotlib line. You will be having an API for that, whatever the API they have provided. Okay, go in there, like you can see here. Search for the line. Okay, and they weirdly haven't mentioned any line here. Okay, they have actually. This is okay. So let me just show some line here. PLT dot. Okay, they don't have it actually. PLT dot line, for to actually calculate a line, we just PLT dot plot. We just calculate the PLT dot plot. It actually plots out the line here. Okay, so we have, let's say, x1. So it will just go into print out the line. In order to print out a line plot, you just need to call out simple plt.plot. And what you can do for the x label, like never actually forget to label your x's, right now I'm giving a x label, plt.y label. Okay, now we have x and y label, and now plt.show. Okay, and yeah, now we have it, right? Okay, so we have covered pretty much like a lot of things, and I haven't taken any questions yet. Okay, so if there are any questions, please do let me know. I will going to address those. And meanwhile, I will be drinking some water. Well, for the histograms, when you want to calculate the frequency of each interval, okay, for the count plot basically helps you to determine the number of to determine the number frequency of any category. Count plot comes handy when you are dealing with the categories. What was the last one? Histogram, I have told you. Bar plot tells you the frequency of a if a value or of a category. Basically, if I have, let's say, 7 apples, 5 bananas, and 10 chikus, I would say I could just plot a bar plot with that, with a bar of 7 apples, 10 bananas, and 5 chikus. Okay, that is how you can use those. Any questions? Any more? Please, guys, bring your questions up. Any questions? Yes, sir. Where to go for the assignment? Yeah, like I usually don't post assignment just after the day one. The reason is like, for the day one, you just understood something. I will going to post an assignment today, because since we have covered multiple, topics, now I can actually form a good assignment. Okay. So yeah, you will be given an assignment today itself. Is module library package same? Package is something that you actually puts with the .init file. Okay. Library is something that when you like when you have multiple functions in a single class, like you can call it a library, and you package that module into, you package that module into a folder. Like, if I actually have to mention it, if I have to actually tell it, right? So module can be, say, as a simple Python file that actually goes into the package, and we import that package as a library. That's it. So difference between matplotlib and cbon. Okay, Vishnuvardhan, basically both are the same, but like both are actually being used for the visualization purposes. When you want to visualize the data, that's where you actually use Matplotlib or Seaborn, right? Okay, so yeah, no, like depends upon the use cases. Like you cannot plot a pair plot with the uh, Matplotlib. Well, in that case, you might need Seaborn. All right. Okay. Any questions? Any more questions? If there are any questions, please ask them out, guys. If there are, I'm taking questions. Like, I'm pretty much done with the Matplotlib, Pandas, and NumPy. All right. I have covered all of them in brief, and there will be an assignment now for all of that. Okay. Okay. Can we convert a feature from float to int? Of course, we can convert a feature from float to int. Yes, vice versa. Just simply apply dot apply, then pass an int or float. You will be good to go then. All right. Any more questions? Please, guys, bring them up, please. We are pretty much done today for Matplotlib. For if you have any questions regarding to any of what I have taught till now, like you can ask me right away, and I will just going to answer those questions. Okay, guys. Any more questions? All right, if not, so can you plot and show curtices of this data set? Like you need to calculate the mean, central, and everything. Honestly, what data set, by the way? Well, you can actually calculate. Like right now, I don't remember the exact API for that. Honestly, what I would do, I would just going to calculate what you can do instead. Like uh, calculate the mean of a column first. Okay, I'm talking about here curtices. Okay, and afterwards, after calculating the mean of that column, see, like just simply minus that mean value from each of the column values. Okay, and afterwards plot the residual values on a distribution plot. Okay, and I believe you should be good to go, like what values that you are having away from the mean. Okay, or that is something. Okay, so that is how I would actually going to proceed with that. uh okay. All right, guys, if there are no any questions, so Josna, can we end?
Yes, sir.
Can we end? We are pretty
Yeah,
much
yeah,
done
sure.
now. Okay then.